All right, so what we're going to do today is we're just going to take an introductory look into SOLIDWORKS CAM Standard, take a look at some of the features and tools that will be available to you guys. Um, so we'll get this presentation started here. All right, so the basics on SOLIDWORKS CAM Standard. SOLIDWORKS CAM Standard is a 2.5 axis CAM programming, and it is built on CamWorks technology, which has been around since about '98. CamWorks was the first gold standard partner for machining with SOLIDWORKS, and so it has been developed right along with SOLIDWORKS from just about the beginning. It is seamlessly integrated with SOLIDWORKS, so it works as an add-in. There is no need for different file types or having different windows open or anything like that. It all works right inside your SOLIDWORKS, and it is CAD independent, meaning that any file that you open up in SOLIDWORKS will be able to be programmed. You know, if it's a step file, an IGES file, anything like that, if you can open it up, it can be programmed even if you don't have a full feature tree for the original file. And SOLIDWORKS CAM is able to do that by using the advanced feature-based machining. So SOLIDWORKS CAM is going to take a look at your models. It's going to develop a feature tree for machining based on that model, and then it's going to apply machining strategies. And so that advanced feature-based machining is built around an automatic feature recognition technology. And that technology looks at the prismatic solid, the volume of the model, and develops features based on some rules. And then we apply the knowledge-based machining to those rules and to those features to develop the machining strategies. The extra nice thing about that knowledge-based machining is that all of the strategies and all of the processes developed over time can be customized to suit your machining practices. So basically what you do is you end up teaching SOLIDWORKS CAM how you like your parts to be machined and what your machining processes are, and it can get smarter and allows you to get your models from model to program to reality much quicker. As with just about anything else in SOLIDWORKS, these are fully associative features. The model and the toolpath are linked together parametrically, so when you make updates to your model, your toolpath will update as well with just a rebuild. It's all super simple and works pretty intuitively with your normal SOLIDWORKS workflows. Next up, and in some cases, the important part here is that SOLIDWORKS CAM Standard is free with your SOLIDWORKS subscription. So as long as you are an active subscriber to SOLIDWORKS, that your subscription is current, you will have access to all of the SOLIDWORKS CAM tools, the CAM Standard tools. And we'll talk a little bit later about the different tools you get in professional, and that's a little upgrade that you can get. So the next thing I'm going to show you here is we've got this model here, and I've got a question for you. How many clicks? And I want you to think not just in clicks, but if you guys currently are programming manually or using another process or another tool to do your CNC programming, think about how long or how involved programming a simple model like this is, right? Even doing it manually or in a relatively simple tool, it shouldn't take too long, but I want to show you how quickly we can get this done in SOLIDWORKS. Once we get through this tool, I do have another example, so we're going to go through the details of the clicks I'm making, but this one is really just kind of to show you how quick the tool can be once you've got it set up for yourself. So we'll just switch over to SOLIDWORKS. Okay, so we've got this model here. I'm just going to go ahead and quickly turn on our SOLIDWORKS CAM. So as I said, it's just an add-in, so it's going to show up on our add-ins menu here, and we can just scroll down here and turn on SOLIDWORKS CAM. And we'll just think a moment while it's loading the tool here. All right, and so what we get when we add the SOLIDWORKS tool in, the SOLIDWORKS CAM tool in, is we get a couple extra tabs up here at top. So we're going to start here with the SOLIDWORKS CAM feature tree, and the only setup I need to do in this case, because I'm just going to use all of the defaults, is I'm still going to have to add a 0, 0 point. So I'm just going to go ahead and add it in here for myself, and then we'll click OK. And then from here, I'm going to use the automatic feature recognition and that machine, the knowledge-based machining processes to develop my features and my toolpaths, all in pretty much one click here. Okay. All right, it's just taking a moment to think about it. And so right now, we see that it's generated some features and some machining plans, and if I go ahead and select any of these, we can see that we've got those toolpaths even already. So next I'm just going to go ahead and post-process it out so that we can get some G-code. And I'll go ahead and get that processed, and so now we have that G-code. And it's all right there. We can kind of scroll through it here to take a look at it. And SOLIDWORKS CAM also comes with a NC editor, so that's a better way to take a look at it. So I'm just going to go ahead and click OK, and it'll open up in the NC editor for us. Just bring that over so you guys can see it. And so here's that program. So yeah, it's a relatively simple program, but what I want to demonstrate here is that once we have ourselves set up and we have our knowledge base tuned appropriately, we can get from model to program in minutes, and it's all right here for us. All right, Andy, I see your question here about post-processors. I'll go into that a little bit more later when I'm showing you the fuller model, and then we can certainly talk, or I'll certainly give you guys some more information at the end of the webinar about post-processors as well. So we'll go ahead and close this out here. So again, super simple, just a few clicks, we were able to get a program that we can go right to a machine with. So I'll go ahead and close this one out, and we'll take a look at the next part. So for this part, I'm going to show you guys a bit of the automatic process along with some of the manual processes. So I just want to make some settings changes here up front to allow me to do that. So when we use our automatic feature recognition tool, we can actually control the features we're going to look for. And so because I want to show you guys a bit of both, I'm going to make sure that the feature recognition is really just looking at the holes in this model. And then I'm going to go through some of the manual processes to program these pockets. So with this set for holes, I'll go ahead and just click OK, and then we can get into the actual process of programming. Yeah, we'll get to, Andy, I see your question here about coordinate setup, system setup. We're going to get to that here in just a second, and we'll go over the basic options you get from the start. So a lot of care and thought has gone into the way the user interface works for this particular program. So it works pretty easily. We can go from left to right here or from top to bottom here to kind of get through all of our setup steps. And then as the process works, we're going to work with our features here in the CAM feature tree. And then we're going to move to the CAM operations tree for our operations. And then we also have the tool tree. We don't so much do a lot in the tool tree, but it is a good source of information. We can also do some sorting and some optimization of our processes here. And we can take a look at that in a moment. So the first thing we'll do is we'll take a look at our machine setup. So for our machines here, I've got a number of selections here for options, and each of these machines can be set up in the tech database to display here, and then each of these machines can then be linked to a specific post processor and even a specific tool crib, if that's the way we have our stuff set up. For this part, I am just going to go with the default mil-inch, but I do have some other machines here set up in my list. So if I knew I was going to a specific machine with this part, I could choose that machine and have that machine's parameters set up front. Since we mentioned post processors a little bit here too, I'm going to go to the post processor tab, and we'll just run down a little bit of that right now, and then like I said, we'll go over more later. With SOLIDWORKS CAM, you're going to get a few dozen here, a couple dozen generic post processors, and these are going to cover a number of fairly common machines or fairly common controllers or controller types. And these are not the only things available, but these are the ones that come built in with the software. We here at DASI have another library with many more post processors available. So we have a large number of generic post processors. If you don't see your post processor here on the list, you can start a ticket with tech support or shoot me an email, and we will see if we have a post processor that can work for your machine. And then if one is not available that's going to work for your machines, then we can talk about the process of getting a custom one created and quoted for you. So again, in this particular case, we're not doing anything specific or real world, so we're just going to go ahead and use the tutorial version, which is based on a FNUC controller. James, yeah, I see your question here. Yes, there are ways to edit the post specific by yourself. The SOLIDWORKS CAM does entitle you to the UPG program. The UPG program is short for Universal Post Generator, and that's the program that CAMWorks has developed to write and edit posts. Once we get to the end, I'll post some information in the chat for you guys so you can see where that's at. And again, if you miss it or if you have any questions, don't hesitate to shoot help desk an email, or you guys should all have my email as well. Go ahead and get a hold of me. I'll be happy to get that information for you. Okay, so now that we've got our machine dialed in, we'll go ahead and take a look at our stock. And so our stock setup has a few different parameters built in. The first thing at the top here is our material type. This list is based on the speed and feed library in the tech database, and it contains a number of materials that we can use, and you can always add or edit materials to this list as well. We'll just stick with 6061 aluminum for this particular part, but I wanted you guys to see that there are other options there. And what that does is, like I said, it links to the speed and feed library, so that will inform the speeds and feeds that are output in the program. For our stock type, we have a few different options here. We have a bounding box. So by default, it's going to go ahead and grab the bounding box of the part. We can then add material in these boxes to that bounding box if we wanted to add material. We can add material in the X, the Y, and the Z, and we can add that in both positive and negative directions. Or I can click this button here to make it a uniform stock edition. I'm just going to stick with the default bounding box for this particular program, but those options are all available for us. The other option is we can use a sketch. So if we had a sketch in our part, we could extrude that sketch to be our stock bodies. We can also import STL files. And then finally, we can import other SOLIDWORKS models to act as stock, or even use configurations of the existing model for that stock. So if you're designing your parts to follow your manufacturing process, you can model one of your configurations as the stock, and then you can model a configuration as the finished machining, and you can use that stock configuration here. Like I said, we're just going to go with the bounding box for this part, but those are all options we have. So now that we've got our stock set up, the next thing is the coordinate system. So I'm just going to double click here to open up our coordinate system. And so by default, it sets us up with the user defined, and I can essentially pick any entity in the model to act as my 0, 0. In this case, I've got the part bounding box vertex selected, and it's going to be this lower left corner here. I could also use the stock bounding box if the stock bounding box was different than the part bounding box. In this case, they're not. They're both the same, so I'll just use that. Our other option here is I can pull down and choose a SOLIDWORKS coordinate system. So we can add a SOLIDWORKS coordinate system in our model as reference geometry, and we can use that coordinate system here to generate our program. So for now, like I said, we're just going to go with this this lower left corner on the bounding box to get us our orientation. And we'll go ahead and click OK. And so now that I've got the parameters set up for the model, I can go ahead and extract the machinable features. And like I said, in this case, I've got it set to just extract the holes, and it's just going to extract the features, and then I'll show you guys how to add the operations. Okay, so it interrogated the model, and it found a drilled hole over here. It found a larger hole here, and then it found this hole group down at the lower left of the part, and then a larger group of holes, this counterbore hole group. So it saw that those holes were all of like geometry and grouped them together so that we can program those all at once, essentially. So now that I've got these holes as features, I'm going to go ahead and generate the operations on them. So I'm just going to right-click and say Generate Operations Plan, and that's going to give me operations for all of these holes. Okay, so now it's moved us from the feature tree over to the operations tree, and it's generated all of these drill operations, and then in the case of this larger circular hole, it generated a rough mill and a contour mill to do that. It also has a contour mill here for the counter bores, because that's what was set up as the default. And even these two last operations to countersink the holes on those counterbore holes. You may notice some little flags here. These little flags are just telling us that these operations have used tools that are outside of the tool crib. And in this case, that's perfectly acceptable, because I don't want to sit down here and take a couple hours to put all of the possible drill sizes in my tool crib. So I can go ahead and let SolidWorks CAM select the appropriate tool and even get the appropriate tool from the library if it's not existing in my tool crib already. So now that we've got these all set up, we'll go ahead and hit the next button here to generate the tool paths. And this is going to generate the tool paths for all of these drills and these existing mill operations. Okay, and so now you may have noticed that all of the stuff here was blue and now it's black, and then previously this stuff was all blue and now it's black. So it's keying on that same blue-black color scheme as we use for our sketching, and so when we see something here that's highlighted in blue either in the feature tree or the operations tree, it basically means that that feature, in the case of the features, it means that the feature doesn't have an operation yet, and in the case of the operations, it means that a tool path has not been generated yet. So in this case, everything's already generated, so we've got our tool paths, and I can even select specific ones to see those tool paths, right? So that pretty much covers all of the holes here. Let's go ahead and add in one of these pockets here. So the first thing I need to do to add in the pocket is I need to recognize the feature. So what I'm going to do here is I'm going to come to my setup, and I'm going to say 2.5 axis feature, because that's what I want to add, and it'll bring us into this command. It's going to ask us for our feature type. Pocket happens to be at the top of the list, so that's where it starts, but we have a number of options here for types of features that we can generate here. Again, pocket is what we want, so we're going to go ahead and go with that. We then have some options for how we can select the geometry. I find pockets are super easy. You can, for the most part, click on the bottom face of the pocket. It's going to grab the pocket, and then when we go to the end condition here in the next step, all I need to do now, I'm going to zoom in here, guys, so you can see it, and you'll see some of the visual feedback we're getting. It's got the pocket highlighted here, but it's going to be cutting more right now than the actual pocket. So to select the end condition of the pocket, I'm just going to click on the opposite face from what I originally selected, and that gives us the up to face feature here. So that, and again, our visual feedback here kind of shows us now what we're going to get for the pocket. Now for the strategies, the default strategy is this rough, rest machining rough and then finish. So it's going to do a large end mill to hog out the material, and then a smaller end mill to clean up the corners, and then a contour cut to give us a nice finish. I have the option of choosing my strategy if I have a specific strategy in mind that I want. Rough, rest, finish is just the default, and then that default can be changed. And again, like I said in the beginning here, the technology database can be trained. So you can even create your own strategies for how you want that to, how you want these pockets or whatever you're machining to go. And those strategies will show up here, and you can even set them to default so that when you get to this point, it is going to be selected first. And then if for some reason you needed to be a different strategy or not use your default, you can always come in and change that. All right, so we've got our strategy defined, we've got the volume of the pocket selected, and we're not actually looking for any islands or anything in this case, so I'm just going to go ahead and click OK to move to the next step. And so now we've got that feature. And we can see, like I said, that that feature is now highlighted in blue because it doesn't currently have an operation. So to go ahead and add that operation, I'm just going to right click on that and say Generate Operations Plan. SOLIDWORKS CAM thinks about it for a little bit, and then it gives us our roughing, our rest machining, and our contour mill. All right, so we'll just go ahead and generate the toolpaths again, and that will give us the toolpaths for these operations as well. Right, so now we can see that they've all gone black. So I'm going to zoom back out a little bit here so we can see it. And what we can do now that we've got all of our everything on there that we want to do for the moment, we can go ahead and simulate the toolpath. And so it blocks out our stock for us, and then we have some controls for our speed. I'm just going to turn this down a little bit here, and I'm going to go ahead and hit play. And this will run through the toolpaths as they are shown in the operations tree. So it's going to go from top to bottom on the operations tree and run through each of the toolpaths there. So now is a good time while this is running. If you guys have questions, feel free to throw them in the questions section here. I'll take a look at them as this thing runs. Yes, James, you absolutely can manually assign tools as well as operations. It's going to grab defaults from your tool crib. So with your tool crib, you can pick out specific tools, and then you can tell SOLIDWORKS CAM only use the tools in the tool crib. Or you can have it based on its internal rules, grab whatever it thinks is right, and then if you disagree with it, you can go into any operation, and there's a tooling tab, and you can change that tool. You can also go to the tool tab in the new tabs and drag and drop operations between different tools in your tool crib. Jeremiah, yes, you can. I was actually going to just talk about that here once we got the simulation done. So as you guys may have noticed in the simulation, it kind of did a lot of tool changes. It did a lot of running around, and it wasn't really optimized. I'm going to show you one other thing here too in the simulation. I'm going to click this button, and this button shows us the difference between the model and the simulation. So green being the model, blue being material that's uncut, and red and sort of yellow are shows areas where the machine has been gouged. So we can see right now that we don't see any significant gouging. There is things that are not yet programmed that can still be gone back over, but right now the simulation has done what we've asked it for. So Jeremiah and Marcus, both you guys had questions about reordering operations in the tree. Yeah, absolutely you can. So I can, for example, just drag and drop like my center drill operations here, so that they're all combined and we don't have a lot of running around and extra tool changes. My other option is I can right click on mill part setup and I can say sort operations. Then I can take a look at my sort options. So I can sort based on my operation type, and then once I've got it sorted by operation type, I can then sort it by tool. So this will combine all the operations, so all of the center drills, the roughing, and the contouring then will all be ordered, and then those things will be ordered again based on the tool they're using. So let me go ahead and apply that, and if you guys watch the operations tree over here, you can see that when I hit apply here, it all is reordered. And so now we've got all of our center drill operations here, and you can even see the center drills are kept together based on the center drill type. Our drills are done here, and then our rough milling is done here, and so we've got the two 3/4 rough mills together. We got a 3/8 end mill, and then we've got contouring, and then more contouring based on that. And so we even have a tool change here between this rough mill and this rough mill before it goes into this contour mill. And since this rough milling doesn't affect that contour milling, I can even drag that up now manually. So now my 3/4 end mill is going to get all of its use before we switch out to a different end mill, right? So that can help maximize our tool time and cut down on extra time tool changes and things like that. Okay, and then so I'm just going to go ahead and hit post-process 2 here just so that we can see that we get code out of this one as well. We'll hit play, it'll think about it. And so that gives us our G code here. And just like with any NC editor, the SOLIDWORKS NC editor, when we open this up, oh, I hit play again, the wrong button. I'll let that finish up. So when I click OK and it opens up the NC editor, I can make manual edits if I need to here. The other thing I can do is take a look at the back plot. So I did my simulation. I did the simulation to make sure that the tool paths look good. Now I can hit the back plot and take a look at the G code and make sure that the G code is also outputting what I expected to output. So we can see all of the different tool movements that are going to go on here, and we can even play through them and simulate it like we did with the simulation. So the difference being that this simulation is based on the G code, whereas the simulation in SOLIDWORKS CAM is based on the tool path. So we can make sure that our post processor in this case is giving us what we want out in the output. Okay, so I'm just going to go ahead and stop that since we've already seen the simulation. Okay, so I'm just going to flip back to our PowerPoint here too. So we took a look at that guy. So let's take a look at the features again. So again, with CAM Standard, you get the automatic and the interactive feature recognition. You get the technology database, a selection of post processors, and the NC editor. So that's all built in with CAM Standard. If you want to upgrade to the SOLIDWORKS CAM Professional, the additional features there are you get indexing in the 4th and 5th axis, you get assembly machining, you get the volume mill high-speed machining, and you also get access to turning. So that's what you will get with the upgrade to CAM Professional. In all of the cases, though, it is important to note that SOLIDWORKS CAM is only 2.5 axis. There are some 3-axis operations you can apply, but they aren't going to do any simultaneous 3-axis machining. So you can do area clearance and step down for clearing out 3D features, but you're not going to be able to then go back over and do a nice clearance path, a nice contouring path for a 3D surface. I see you got a couple more questions, which is good because it's time for more questions. So let me take a look here. Mill turn. SOLIDWORKS CAM does not have mill turn available. If you need mill turn, you'd have to go upgrade from SOLIDWORKS CAM into CAMWorks. CAMWorks does have mill turn and live tooling and that sort of stuff. So James, if that's an important feature for you, you'll want to look at moving to CAMWorks for that. And then Mark, what assembly machining is it would allow you to create assemblies in SolidWorks and then program those assemblies. So in a lot of cases, what we're looking at is machining, modeling up all of our fixturing, so we can model our tombstones or vices, or if we have fixture plates with multiple versions of the part getting machined, or even a fixture plate where one half of the fixture is machining the top part and the other half of the fixture is machining the bottom of the part. You can model that all up as assemblies and then program it in SOLIDWORKS CAM Professional, which will allow you to set your avoid areas and make sure that your tooling doesn't crash into any of your fixture plates or anything like that. So the question of is there a tool power or torque function? So can we look at the torque being put on the tool as it goes into tight corners or things like that, and control the feed and speed? I'm not sure that there's specifically a function for that, whereas where we can make settings or set specific limits. SOLIDWORKS CAM does adjust for those things, and if especially if it's a specific feature of your machine, that's certainly something that can be added into the post processor, so that when your post processor outputs the G code, that appropriate G codes or M codes are used for the machine to do that sort of monitoring. So that can be done, but I don't know of for sure how it's being done out of the box. But what I can do here, John, is I'm going to go ahead and take your name down and do a little bit of looking, and I can get your email out of the attendees list here and shoot you an email on what I find. So the next question I've seen here is, does CAM Standard include any adaptive strategies without purchasing the upgrade for volume mill? I guess I'm not sure what you mean by adaptive strategies. If you're talking about the toroidal sort of tool paths and that sort of tool path generation, then yeah, that's only available when you get the volume mill with the CAM Pro. If you're talking about something else, I guess I'd need a little bit more clarification on what you mean there to get you a good answer. And as far as, and then Andy, you're asking, what about entering speeds and feeds? Speeds and feeds are pulled out of the speed and feed library in the tech database. And so the tech database and the speed and feed library can be edited so that you're getting speeds and feeds that you like. You can also edit the individual operations, or even in the NC editor, edit the G code to get a specific speed and feed as well. So yeah, that's all in the tech database where you would set up your defaults. But if, for example, you're using a different material, or you're not sure what you want to do and you want to be able to adjust it on the fly, you can adjust it on the fly in the operations and in the G code. John, so yeah, what volume mill is it's a high-speed machining strategy, and what it does is it looks to optimize your cutter usage, so that you can cut on as much of the cutter as possible throughout the entire movements of the tool, and this helps move through the material faster. It also helps reduce tool wear. It's a pretty neat process, and it's so essentially tools go to depth, and instead of just using the bottom of the cutter, we use a percentage of the side of the cutter and the bottom of the cutter to generate the most efficient tool path we can. All right, so that looks like all of the questions I've got right now. Are there any other questions I can take a look at? Okay, Charlie, does the system recognize toolbox hole sizes and use the correct tools to program from the toolbox? That's sort of a trick question, because what SOLIDWORKS CAM does is it looks at the volume, the prismatic solid, so it doesn't actually look at the SOLIDWORKS feature tree, and that's what makes it CAD independent. So it's going to grab those sizes, and it will recognize a threaded hole versus a just a drilled hole. But if it's not, it may then go to the tech database to pick up the specific drill sizes to use. So in that sort of case, you just want to make sure that your drill sizes are set up in your tech database as well as your toolbox to get those things to operate on the same wavelength. So tolerance-based machining is another feature that comes in the SOLIDWORKS CAM, and what that does is it takes a look at tolerances placed in the model with DIM Expert and or surface finishes, and it applies and again it applies strategies based on those tolerances, and it's then going to machine to the median tolerance, as opposed to, so if you model your pocket at 2 inches by 2 inches square, and then you've got a plus 30 thousandths and a minus 10 thousandths tolerance on it, instead of just machining to 2 by 2, it's going to look at the median value of the tolerance, and it's going to machine to that median value, so that you get your parts in the middle of your tolerance range all the time. So yeah, the CAM system did use an end mill instead of a counterbore. You could change that on the fly. You can also set up the tool in your tech database, in your tool library, so that it has a counterbore tool that it uses as opposed to an end mill. You can also set up things multi-stepped holes. So if you have things like fluid power ports or specific hole geometries where you have a specific hole drill that maybe has different diameters on it all on the same tool, you can also add in those custom tools so that the tool is just done in one hole. Yeah, the default tech database, Andy, isn't set up to have counterbores in it or to do counterbores in that way. It would just be a matter of me, like I said, setting up the tech database to do it in that process. Thank you for coming, Kevin. I hope I hope that showed you what you're looking for. John, my understanding is what it sees is the cosmetic thread. So it sees the cosmetic thread and recognizes that as a thread, and then uses the size of the hole to determine the thread size. Good question, Charles. The tech database is not, or the automated feature recognition isn't going to see the fit classification, I don't think, based on the way it reads the model. So that would be one of those things, again, where because it is a machine, if it's a specific machining practice you do all the time, you'd want to set up your tech database to consider the fit classifications you're going to use. Whereas if it's sort of a one-off thing, you can always go into the operation and change the tool, or change the tool and then add a reaming operation or things like that to get the fit size that you want. All right, guys. Well, we're coming close to the end of our hour here. I'm happy to keep answering questions for you, but if nobody else has any other questions, we can go ahead and stop here. And then, like I said, look for this whole webinar has been recorded, so I'll get that to our web folks, and they will get it up to the web however works best, and they should send out some information to you guys on where it can be seen. All right, thanks for coming, everybody. I hope I was able to answer questions for you and give you guys a good first look at the new CAM tool.